The conceptual development of an elevated U-turn, particularly at C5 Kalayaan, has been developed by MMDA through the continuous effort of this authority to seek new ideas and alternatives to improve our traffic condition in the metropolis. Using a traffic simulation software called VISIM as a tool, this authority was able to come up with different traffic schemes to find out which among the possible options would result to a better traffic condition in the area. Let us start with the option 1. Option 1 is a 4-phase traffic signal system without U-turn slots. This simulation resulted to an average travel speed of 18.63 kilometers per hour. This is the existing traffic management scheme in the intersection before modification was introduced. Option 2 will implement total closure along Kalayaan, simultaneous with U-turn slots. This idea has been implemented and is continuously used in some areas, which actually resulted to a faster travel speed like in EDSA Quezon Avenue, EDSA Muñoz, and EDSA West Avenue. In C5 Kalayaan, however, the simulation resulted to a very low average travel speed of 6.96 km per hour. Thus, option 1 is better than option 2. Option 3 is a 2-phase traffic signal system combined with U-turn slot. Traffic simulation report for this scheme resulted to an average travel speed of 17.85 km per hour. Relatively okay, but option 1 is still better. In option 4, we applied traffic signal modification and optimization, resulting to a 3-phase traffic signal system and U-turn slots. As you can see in the figure, vehicles coming from Pateros will have to use the U-turn slot in order for them to pass through Kalayaan going to EDSA. In this scheme, we obtained the best average travel speed so far as compared to the first 3 options, the result being 31.75 kilometers per hour. Still looking for other possible solutions, we came up with the introduction of an elevated U-turn, which we tested and analyzed as option 5. In this traffic scheme, total closure along Kalayaan can now be implemented as the merging conflict is dramatically reduced. The simulation resulted to an average travel speed of 43.68 km per hour. This is obviously the fastest average travel speed among the options presented. We also took into consideration the proposal of DPWH, which is an underpass along C5 in combination with a 4-phase traffic signal at street level. This resulted to an average travel speed of 31.61 km per hour, just about the same with option 4. As a result, the elevated U-turn is still the best option. To demonstrate a comparison, here is another short clip simulating the traffic flow upon the implementation of the elevated U-turn at C5 Kalayaan. As you can see, vehicles from all directions going to any destinations is continuously moving. The intersection will be a stand-alone interchange, meaning traffic management authorities would not need any enforcers, nor maintain expensive traffic signal facilities, no 24-hour lighting and water pumps to take care of the flooding as in panel structure. This slide shows a schematic diagram of elevated U-turn using the volume of vehicles projected at 2015. The merging point is the point of conflict between the vehicles from going down the elevated U-turn and those who are entering or going up the U-turn ramp, which is duplicated in other side, resulting to two merging points. At the most, there will be 889 vehicles merging against 267 vehicles during peak hour, with a merging distance of 200 meters. In order to clearly visualize what will actually happen, we can compare the situation with the present condition at the Balintawak-Cloverleaf interchange. Volume count conducted this present year 2005 show that there are 1,176 vehicles merging against 976 vehicles during peak hour within a merging distance of only 180 meters. This indicates a situation more critical than the elevated U-turn. The following table shows the matrix of similar information at other locations with merging conflict, with NMDA's existing at-grade U-turns as the basis of comparison. The table will show that elevated U-turn has the least conflicting vehicles and has the second longest merging distance among the samples. The depressed bypass will cater vehicles along C5 at Kalayaan Junction at the speed of 44 km per hour, but will only allow 18.74 km per hour average at grade level due to four-directional conflict, which will be managed by four-phase traffic signal facility. On the other hand, an interchange, which will be provided by a pair of elevated U-turn bridge, shall provide 56.84 km per hour speed along C5 and a 30.07 km per hour average at all other directions. As can be seen, there is a marked increase of travel speed in any direction. In addressing traffic congestion at intersections, there are a lot available solutions, including grade separation with the use of flyovers and tunnels, signal control at grade U-turns, and the latest idea, the elevated U-turn bridge. Careful study, however, should be made in order to arrive in a better, if not the best, solution, considering the current economic situation and limited funds available, the urgency of the implementation and the inconvenience to the motorists and the general public. Consideration with the adjoining intersections and behavior of traffic in the area should also be a matter of concern in the finalization of the plan.